In this video, we'll be solving a question on method of moments. We have the uniform distribution given over an interval. This is the interval. And we are asked to estimate mu and sigma by method of moments. For more on this topic, you need to subscribe to this channel. Solution. Our interval given is mu minus square root of 3 sigma and mu plus square root of 3 sigma. And we should note that for uniform distribution, it has a mean of a plus b all over 2 and b minus a all squared all over 12 as the variance. More so, for method of moments, the population mean is always equal to the sample mean. And we have our population mean to be equal to the expected value of x, which is equal to a plus b all over 2. And from our interval, we have it as mu minus square root of 3 sigma plus mu plus square root of 3 sigma all over 2. So this will cancel this. We will now be left with, this will cancel this. We will now be left with 2 mu all over 2. And if it cancels, it means that our population mean, which is expected value of x, is equal to mu. Our sample mean is equal to 1 all over n summation of xi. And we know that this is equal to mean. So if this is our equation 1 and this is our equation 2, we say combine equation 1 and equation 2. When we combine them, we get the mean to be equal to mu. Get the mean to be equal to mu. Because the solution, we must combine them. Because the solution to the method of moments is the population mean must be equal to the sample mean when combined. Also, for the second moment, the population mean is equal to the sample mean. And we have the population mean, which is this, to be equal to the expected value of x squared. The sample mean to be equal to 1 all over n summation of xi squared. So this will now be our next equation, because this is the equation we will combine. So first, we can put it down. We can put it down here. Mu, the population mean to be equal to the expected value of x squared, and the sample mean to be 1 all over n summation of xi raised to the power of 2. So we'll come to that. You should note that for our uniform distribution, the mean is a plus b all over 2, and the variance is b minus a all squared all over 12. So how do we get the expected value of x squared? we note that the variance of x is equal to the expected value of x squared minus the expected value of x all squared. So we make this the subject of formula because this and this are the same thing. So we have that the expected value of x squared will be equal to the variance of x plus the expected value of x all squared. So we note that our variance is this, which is b minus a all squared all over 12 plus this, which is a plus b all over 2 all squared. So what is b minus a? B minus a is the interval, which is b is this, which is mu plus square root of 3 sigma minus a, mu minus square root of 3 sigma all squared all over 12 plus we have this as a is mu minus square root of 3 sigma plus mu plus square root of 3 sigma all over 2 all squared. So we'll have this as, if we open the bracket, we'll have mu plus square root of 3 sigma minus mu plus square root of 3 sigma all squared all over 12. And we have here to be plus. Of course, this will cancel this and we'll be left with mu plus mu, which is 2 mu all over 2 all squared. 2 will also cancel 2. This is still our expected value of x squared. This is what we are looking for. We'll still move over to this place. We move over to this place. Now, our expected value of x squared is equal to mu will cancel mu, will now be left with this plus this. So we have 2 square root of 3 sigma all squared all over 12 plus mu squared. This is what we get, which is also equal to, if we open this, we get 4, the square will cancel this, multiplied by 3 multiplied by sigma squared all over 12 plus mu squared. So this is 12, it will cancel this. It then means that our expected value of x squared is equal to sigma squared plus mu squared. So this is our equation, say 3, and this is our equation 4. Combining equation 3 and equation 4. Combining equation 3 and equation 4. That means combining these two. See what we'll get. Combining these two, we'll get, because we'll have our sample mean to be this, and we'll have our expected value to be this. That is, we can still write it as, this our equation 3, we can still write it as sigma squared plus mu squared, equation 3. So if we combine them, we get sigma squared plus mu squared to be equal to 1 all over n summation of xi squared. Of course, we know that mu is equal to x bar. So we can clean this. We can clean the whole of this. Mu is equal to x bar. So we can write this as sigma squared plus x bar squared to be equal to 1 all over n summation of xi squared. This can go over to this other place to give us sigma squared to be equal to 1 all over n summation of xi squared minus x bar squared, which is the same thing as the whole of this. We can write it as 1 all over n summation of xi minus x bar all squared. So our sigma estimate will now be equal to, we square both sides, it will now give us the square root of summation of xi x bar all squared all over n. So this is how we can obtain the estimate for mu and sigma by method of moments when we have the uniform distribution density with interval this and this. So we already get this as our estimate. We already know that our mu we got for the first moment is equal to this. So this and this becomes the estimate for mu and sigma. For more on this topic, you need to subscribe to this channel.